Hello and welcome to this topic on engine indications. This is for the Airbus A320. We have 6 sessions in this particular topic. Session 1 is overview. Session 2 will be on the ECAM system. Session 3, the EVM system, and you can write that down in your notes. EVM stands for Engine Vibration Monitoring System. Session 4, we're going to go over N1 and N2 indicating systems. Session 5 will be the actual sensors. We'll describe a little bit on the N1 and N2 sensors. And our last session is session 6 on the engine exhaust temperature sensors and the indications. Session 1, overview. Well, what can go wrong with engines? You know, what's the aftermath when it does? If the pilot has no way of knowing, of having some knowledge, namely something displayed on the cockpit, then they can't make adjustments, right, if something seems to be going wrong. There's a instance with Partner Flight 394. This was in the Northern Europe, and I'm not going to go into major detail about it, but this was a rather significant aircraft accident. Not only did it involve, it involved defective parts for different components, but really what I wanted to emphasize on this particular accident was the vibration that occurred, because the APU in the APU compartment was not completely bolted down. On top of that, the one mount wasn't even bolted correctly, but what's worse is the other 3 were actually mounted or secured with defective bolts. So of course it jeopardized the entire security of the APU in the APU compartment. So in that instance, the APU actually started vibrating because it started loosening up and created this domino effect. Okay, we're talking about resonance. And what that does, and if you're not familiar with that, it creates a resonance within the structure of the aircraft, and it just gets, the amplitude of that just gets greater and greater, and to the point where it's kind of like if you have a certain sound and you have glass, right? If there's a certain frequency, you can actually shatter the glass. It's a similar idea or concept that we have here with vibration. So, that's a threat to the aircraft, and that's why there's a monitoring system for that. But anyway, at the end of the whole thing, it was a disastrous and very fatal. It was a fatal accident that actually caused the airplane to disintegrate in midair. And you can go look at all the investigation and the aftermath of that. That's Partner Flight 394. So you see why engine indication is important. To have that in the cockpit for the pilot to make the adjustments necessary. Okay. All right. What gets targeted when we're talking about engine indications? Obviously, we're talking about the engine, but what specifically? Because when we talk about the engine, there could be different aspects to that. But specifically, we're talking about the fans. So we're talking about the fan speeds, of the 2 rotors. So we're talking about N1 rotor, your N2 rotor, and monitoring that speed, as well as your exhaust gas temperature. And Rick is going to be actually doing a piece on this, just to give you a better understanding of the importance of it. Okay, so here's some questions to think about. What are the main parameters? Okay, what are the main parameters that are important to a pilot? Why show only certain parameters? Okay, well, we're talking about related to the engines, but it's not going to, it can display some things. In this particular lesson, by the way, I'm not going to go over every single main parameter. So if I mention what I mentioned, it doesn't mean that's it. Which main parameters, and just so you know, so we understand each other here, propulsion survey parameters, I'm talking, those are the main parameters. So what am I talking about when we talk about management? Because we're talking about management and monitoring. Okay, we're talking about management of power, of engine power. And N1 and N2 are very significant. So those speeds are monitored and measured, and we have certain percentage of speed where we can have we can have overspeed, and that becomes a problem because it's an inverse relationship to the thrust. So anyway, just kind of some relationships we can share actually with you if you're interested in any of the physics part of it. Those will be separate lessons altogether, and those are going to be, as far as for now, is going to be free. What are some examples of secondary? All right, so we have main parameters and secondary. Okay, main and secondary parameters. Your main parameters are going to be your N1, your N2, like I said, your EGT, your engine exhaust, your engine gas temperature, and then, which is your exhaust, and then you also have your secondary. Now your secondary are going to be like your bleed air pressure, your oil pressure, oil temp, quantity indications, okay, things like that. And I'll mention a few other things. Some of the examples of some of the, I should say well, some of the actual components, okay, well, you're going to have sensors, and you also have control computers. So you have computers for that are tied to your engine vibration monitoring system, and of course, you know, also with you know, being able to process the information coming from the sensors. All right, so kind of giving you a helicopter's view. That's pretty much, you know, pretty much sums up the entire topic that we're going to be going into. I'm just going to get into detail on, you know, each of these. But okay, so what's the threat? What are we concerned about? What do we have to make sure of? We got to make sure of N1 and N2 speeds, you know, that they're not too low or too, you know, there's not an overspeed. Number 2 is your exhaust gas temperature. That temperature has to be monitored very carefully. You don't want to have it exceed certain limits. And of course, the vibration, keeping vibration to a minimum, not just because it's noisy, because that's certainly one of the aspects, but because of what I described with the airplane accident, you know, the Partner Airlines Flight 394. All right, so it gives you an idea with what this is all about. And just to mention about the ECAM. ECAM, by the way, is the electronic centralized aircraft monitoring. Okay, that's what that is. That's what it stands for, ECAM. And you have your upper and lower. Your upper is going to be for displaying warnings mostly, okay, your warning messages. And then the lower ECAM is going to be designated as the system display. All right. Okay, let's go ahead and move on to, that concludes session 1. We'll go ahead and move on to session 2 so that we can understand a little bit more about the ECAM system and what interfaces there are and what gets displayed. Well, what makes up the ECAM system? And this is the test question, and we'll go over some questions in a little while. But okay, the ECAM system, you got computers. Remember I said you got to have some computers receiving information or signals from the sensors. You do have the flight warning computers, so that's one kind. You also have display management computers. There are 2 flight warning computers and 3 display management computers. You also have 2 display units. That's all part of what makes up the ECAM. And of course the ARINC 429 bus, that's your data bus, which is it's standard in being the transmitter or the conduit, if you will, from your signals coming in from sensors going into either an ECU or directly to the ECAM, or to the computers that go to the ECAM. So, you know, on display. So you have those, the DMC, your FWC, okay, your DMCs, your display management computers, and your flight warning, or FWC, flight warning computers. Those are receiving, remember, are receiving those signals from ARINC 429 data bus. And the ECU, that's coming in between the sensors signals and, you know, and the computers. Now, as far as data, engine, your EWD, which is your engine warning display, that is dedicated to your primary engine parameters and warning messages. And by the way, that's your upper ECAM. That's what I mentioned earlier, but just so you get an orientation. Your engine warning display is your upper ECAM. The system display, or designated as S/D, is system display. That's dedicated to propulsion survey parameters. Those are just giving you readings for your N1, N2, etc. But as far as warning messages coming up on the screen, flashing, pulsing red, words, those are going to be showing on the upper ECAM. Okay. Now the ECU has information that is going to be used by the display management computers. And just, I said there were 2 display management computers. One of them actually drives the engine warning display, and that's going to be your DMC1. Okay, so your display management computer 1 drives your engine warning display, while your display management 2, or your DMC2, drives the other display, which is your system display. Right? Okay, so it gives you an idea of of kind of the split with the way the computers are interacting with via the ARINC 429 data bus and the ECU and the sensors, signals. All right, what can you possibly see then on the upper ECAM? Well, some of the things that you're going to see are going to be related to N1 and N2, so those are going to be there. For example, you're going to you might see N1 exceedance, your max N1, your N1 TLA, which by the way is a white circle. Also your thrust limit mode, actual EGT, your max permissibles for both N1 and your EGT, rotor speed for N2, your fuel flow, and also your engine anti-ice on. Okay, engine anti-ice on will also potentially be showing on that upper display. Now, what about on the lower part of the ECAM? What kinds of information can you find there? Okay, that would be, for example, oil filter clog indication, and also for your fuel filter clog indication. You also have oil temperature and your engine bleed pressure, nacelle temperature indication, the oil quantity. You mentioned oil quantity, your pressure also for oil. So things like that. All right. All right, so that's what to kind of give you an idea of what you're going to see upper and the lower. Now, as far as your fault indication and warning, remember I was saying about the upper ECAM being your EWD, okay, engine warning display, and you have your flight warning computers. Okay, so those computers, what are they? What's its job? Okay, those warning computers are going to be responsible for initiating the chimes or any kind of warning that needs to be displayed, okay, based on the information it's getting. So that's what that's for. It's what it's doing. Your display units, okay, those are your upper ECAM and lower ECAM display units are receiving information obviously from your display management computers, and and so you have that. But the FWC, obviously warning computers are having to do with warnings. Okay. All right, and just know a little piece of data, just kind of, it's I don't know how important it might be to you, but just note that when you have the flight warning computer, it's calculating it's the flight phase for use in the warning messages logic. It's basically it has to constantly be monitoring, okay, because the aircraft is in different positions, right, in different flight phases from takeoff to landing, so it has to be able to handle all of that. Okay, now just so you know, the FWC and the logic that's used, that it uses, is applied as an inhibit during specific phases, and actually in most phases. I think in a couple of phases it doesn't do that, but for the most part, you do have the flight phase inhibition. Okay. Now also, you've done scheduled maintenance and there's unscheduled maintenance, per the manual. So with here, you're going to have a display of scheduled maintenance faults, and those are going to be there's going to be actually transmitted to your centralized fault display system in the menu mode only. So that'll be there. Okay. All right. So that's giving you an idea with the indications as far as what parameters you might see on the upper and the lower displays. Okay. Before I go any further, though, I do want to make sure I get some test questions in here for you. And it doesn't necessarily mean every single one of the ones that we cover in this lesson are going to be on the test, but at least you'll have the answers handy. You'll have the questions there, and and plus you're learning what this is. All right, let's just go through session 1 questions. It's very short. Number 1, what sensors are indicated in the cockpit? Okay, is it N1 and N3 engine sensors, or N1 and N2 speed sensors? All right, so that's the second choice. One example, by the way, not most of them are multiple choice, but sometimes you might see a true and false statement. One example of an engine indication is the engine vibration. Is that true or false? Okay, that's true, right? All right, let's go ahead and cover some questions for session 2. This is on the ECAM system. All right, which part of the ECAM, I'm on number 3. If you're following along in your handout, this is question number 3. Which part of the ECAM will you see an indication for EGT exceedance? Is it the upper or the lower? It's going to be on the upper. Okay, number 4, what part of the ECAM will you see oil pressure indication? That's going to be on the lower, right? Number 5, which 2 components are used in engine monitoring? Is it the FWD and ECAM, or the ECU and ECAM? Okay, ECU is your electronic control unit. Okay, the answer is B. ECU is acting like an interface with the ECAM. All right, number 6, the upper ECAM shows the engine warning system and the lower ECAM shows the system display. Is that true or false? That's true. Number 7, what comprises the ECAM system? Is it option A, 2 FWCs? You can read on your if you don't know what they stand for, you can read it on your handout. 2 FWCs, 3 DMCs, and 2 DUs? Or is it 2 EWDs, 3 ECUs, and 2 EMCs? Okay, the answer is the first answer. All right, number 8, the cockpit engine propulsion system status and warnings are generated by which computer? Is it the first choice DMC, or is it the second one FWC? Okay, second choice, right? Flight warning computers. That's where you're going to have warnings that are going to be displayed. All right, so that's sessions 1 and 2. Let's go ahead and go over the engine vibration and see what's all involved with this system. With engine vibration, it's important to understand, why it's in place and why it's important. And I know I mentioned to you about the accident. Resonance is important. It causes damage to components of the engine if you have something not secured properly. And of course, there's normal vibration. We're just talking about, when something's running in motion, you're going to have vibration. It's just physics. But when it goes past a certain amount, then it can be potential problem for the component itself. In other words, just jeopardizing the structural integrity of that component, and also neighboring or related components. All right, so what do we have here with the engine vibration sensing system, or monitoring, either way you want to call it, but it's monitoring the vibrations on the ECAM. And what is it? What is maintenance staff looking for? Okay, what do you want to look for? What information that you have here is going to be frequency analysis for component vibration search, vibration indication, okay, and excess, also your excess vibration, storage of balancing data. And by the way, if you're not familiar with balancing, that's a whole another interesting topic or theory you want to understand about balancing and unbalancing when we talk about mechanical parts, okay, mechanical objects. But anyway, that's what that is just being able to balance the power that is, exists in a, closed system or semi-closed. And this is what it's giving you. It's giving indication of, but it's storing that data in the ECAM. You also have the byte and MICDO communication with the other aircraft systems, and also the accelerometer selection. We'll get into a little bit more about the accelerometer section selection, because you're going to find that that's going to be kind of the way to tweak, if you will, the balancing. Okay, so but that shows the selections there. The engine vibration system, what comprises, just like we talked about, what different components or whatever's part of the ECAM, and here we're talking about the EVM, okay, engine vibration monitoring system. We have engine sensors, okay, so we do have vibration sensors. We also have another little computer called the engine vibration monitoring unit, okay, and it is a computer. That's going to interface with both the engines and also with just other aircraft systems. Your vibration information is going to the ECAM, of course, and also going to two other systems. It's going to your centralized fault display system, your CFDS, and also your aircraft integrated data system, your AIDS. Okay, those are the other two besides ECAM that vibration information is going to. What are these things for anyway? Let's talk about the aids. I'll just mention, because they're each they're all separate functions. Your aid system, that's used for troubleshooting and condition monitoring. So that's what that function is there for with the aid system. And then your CFDS is to initiate your tests, reconfigure sensors that need to be reconfigured, and also to print previous leg reports or recall them. If you need it to do that, you go to the CFDS. It's also a place for the frequency analysis data, okay, to be. So kind of giving you an idea with new systems, your CFDS, or introducing new, and then your aid system as it relates to the engine vibration monitoring system. I mean, it's pretty cool stuff. You really get into understanding the dynamics that are going on when the engine is running at the speeds that it's going. It's really, the whole thing's just fascinating if you're into the physics of all that. Okay, the whole idea is just being able to control, right? I mean, you have an aircraft that if something's gone off where it needs to be in normal mode, now what? How are we going to fix it? How are we going to get it back to a kind of center? Okay, so that's what we're doing here. Now let's talk a little bit about the unit itself. The engine vibration monitoring unit is what I'm referring to, and this unit is communicating, of course, with the CFDS. I mentioned that earlier, and it's going to be communicating in either the maintenance mode or normal mode. It's also communicating with the aids for vibration monitoring, because remember, aids is a troubleshooting function. And then, of course, you have the recording, vibration recording. Those are made at 5 different engine speeds. That's going to provide information for fan trim balance procedures. So it's gathering different. It's kind of like checking at different points of something to just, and then taking almost like an average. We're going to talk a little bit about the average, because there's another place where we're talking about the sensors where it's actually taking an average of the information, okay, basically the energy that's there or power to to have an output, okay, so that adjustments can be made. Anyway, so where is this located? Where's the engine vibration monitoring unit located? Okay, that's located in the right hand aft avionics bay. So in case that's a test question, that might be a test question, where's the EVMU located? It's located in the right hand aft avionics bay. All right. And what are your interfaces, obviously besides the CFDS? The EVMU is going to be receiving analog. Remember, there's analog and there's digital form of things. Your analog will be coming from your speed sensors, straight from the sensors, and I'll go into a description of what they look like, and of course there's pictures, but it's just those sensors are what's sending out analog systems that the EVMU is going to be picking up. Okay, it also is receiving not just from the speed sensors, but also from the accelerometers. And there's two of them per engine. So there's another, besides sensors, you've got accelerometers where those signals, analog signals, are going to the EVMU. All right. And as far as the supply for the EVMU, I mean, I know it sounds silly, but actually when I was doing the Boeing Gen Fam, I would mention this because it sounds so simple and silly, but this actually has happened to aircraft mechanics where they just flat out didn't realize, maybe we had to plug it in. Power, so I know it sounds simple and silly, but do make sure that you have that it's not just a power supply issue. If the EVMU is not working or something. But anyway, just so you know, that's supplied with 115 volt, pretty standard voltage, for many of your components. Okay, so, just so you have that information. And then you've got also your channels. Your engine vibration measurement channel is made up of transducers, and also your monitoring unit and vibration indications in 1 and in 2. And those are going to show up on the lower part of the ECAM. You also have a signal conditioner on the EVMU, and that's made up of different modules. You've got a 2-channel module, a balancing one, data processing, and of course your power supply mode. So those are your different signal conditioners on the EVMU. And as far as you know, modules are not all of them, but the majority of the components that you'll be working with, and you've already experienced this, they're easily installable. So you can just remove them as a module and replace it with a new module if there's something wrong with that one. So they're very removable parts. Okay. All right. Let's do a few questions and then we'll get into a little bit about the modules, but let's just do a few questions. All right, session 3. I'm on number 9, by the way. All right, question number 9. What does the engine vibration monitoring system do? Is it A, provides maintenance personnel with byte and MICDU communication with other aircraft systems, or does it provide maintenance personnel with data on N1 and N2 rotor speed? Okay, so first answer. Okay, number 10, what comprises the engine vibration system? Is it the EVDS and the engine sensors, or is it the EVMU and the engine sensors? Okay, it's B. All right, number 11. What 3 systems receive the vibration information? Okay, is it the first answer, the CFDS, AIDS, and the ECAM, or is it the CFDS, CLAC, and the ECAM? All right, it's option A. Okay. All right, so we'll come back to questions in a little bit. Let's go ahead and go back and just get a brief idea of the different modules. Your balancing module, for example, is receiving signals from the accelerometers and also an N1 signal. Your data processing, I know I mentioned that briefly, but your data processing module is going to be getting information from the CFDS. Okay, your power supply, of course, providing is a supply module. It's receiving power from the 115 volt bus, right? Okay. All right. You can, there's diagrams, and we can get some more information for you as we can get it for you. to help you better understand where these things are, what the displays look like, etc. Okay, now let's go a little bit into frequency analysis, and then kind of the whole idea about unbalanced, because what happens when you have unbalanced data? Well, you have a job, because if we had balanced data, everything was great, well, then we wouldn't need you, right? So then when there's unbalanced data, what do you do? We have frequency analysis, can do the EVMUs doing a frequency analysis if it's requested from the MICDO on the ground. And it can do that at a selected either N1 or the N2 speed, and it's going to be using an accelerometer to do that. The unbalanced data, when you have, remember I said it stores it, that's what the EVMU does. It can store that balancing data during cruise phase at 5 different predetermined different engine speeds. So again, it's gathering kind of at different points, and I'm talking about engine speeds, to get a better analysis of what's happening, what's not balanced. And then the measurement of course, the EVMU is going to be measuring the position and the amplitude. If you don't understand about mechanical vibration, you've never really studied about amplitudes and frequency and just terms that are basic physics, and I'm moving through here and you don't even know what I'm talking about, you can certainly ask, and at some point if it's something in demand where you want to understand it, we might just put it out anyway, because we like to do that. But if you really want to get into that, it's really fascinating, and we can provide that. The amplitude of the rotor unbalance of each engine. So it's very important, okay? Because remember what I said, if you have the unbalancing of energy, for example, in that APU that should have been mounted, by 4 bolts completely and securely, and one of them started, one came off, and now you have an unbalancing of this, of the component, the APU, then you're going to have a misdistribution, and that's going to always obviously cause strain more on other parts of the APU than having it more evenly distributed. So it's that's the whole idea with the EVMU, is being able to measure all of that information. Okay. All right, and then of course you have the equipment here. The EVMU contains a byte, so that you can detect the internal and external failure of what's going on there. So that's what it has. Your byte maintenance and fault information. What's it checking? So once you initiate the test, what is it testing for? It's going to be testing for the timers. The following parts of the EVMU. So EVMU, so it's going to be checking the non-volatile memory, your analog to digital converter, because remember what I said about sensors, even your accelerometers, are going to send signals in analog, and then it'll be converted to a digital form, so the computers can be reading that, and then obviously sending that information to the ECAM. Okay, I do want to mention the number 1 bearing vibration sensor assembly, and I think we're going to just do a separate piece on understanding, why. The number 1 bearing is important. If you I've seen a diagram of the engine itself, and here we're talking about CFM56, but there's several bearings, and they're numbered. And there's different kinds of bearings, right? If you're engine guys, you would know. If you're not, and maybe you've just done structures only, or structures mechanics, then you may not know. But the number 1 bearing is taking kind of the brunt a little bit, like brunt of the load, and this is why the number 1 bearing vibration sensor is there. It's important to be monitoring the number 1 bearing. So here, this is related to fan trim balance, okay, being able to balance everything if we have a monitoring of the vibration of the number 1 bearing. This is, just so you know, the sensor that's involved with this is not a line replaceable unit. Okay, remember I said a lot of components are, but this particular assembly is not. Okay, so what happens if it doesn't work? Okay, the turbine, this is a turbine, by the way, it's a turbine rear frame sensor, your TRF. Has to be selected through your CFDS in the maintenance mode. Okay, and then, you know, follow procedure from there. Okay, and as far as the accelerometer here, as part of the vibration sensor, this is located at the 9 o'clock position. Okay, on the number 2 and number 2 bearing support. That's where it's located. Now, the sensor itself, and I want to compare once we get through this and when we start talking about N1 and N2 speed sensors, because your speed sensors are, you know, are constructed differently than this one. So I wanted to point that out. With this particular sensor, you have a bracket with 2 holes. It's ensuring obviously that attachment to the engine, and then you have the sensing element. Okay, your elements are made up, you know, of some kind of magnetic material. Also, of course, this is a cable that's going to have your tubes, your plates, 2 conductors, obviously, and you have shock absorbers. Absorbers as part of it, and that's just to, you know, dampen the cable in the tube through the fan frame. You've got a 3-pin connector at one end, and that's just when you have the nut there, so you can connect it to the fan frame, right? So, okay. Now the sensor itself, as most sensors are piezoelectric, so it's going to be using pressure. Piezo, by the way, piezoelectric just means you're using pressure to create electricity. Okay, so that's how that works. And with here, you've got a stack of these discs that are piezoelectric, and they're placed between a mass and the base. Okay, so that what happens if there's vibration going on, then you're going to have that mass exert a force on the discs. Okay, and that's how that's created. It's going to create a signal, etc., on down. But that's just giving you an idea on the, you know, what comprises this particular sensor. I mean, it's still a cable, just like you have with the N1 and N2 that we're going to get into, but it's not as involved, I think, as N1 and N2, as far as the different components in it, of it. Okay, so that's your in number 1 bearing vibration sensor assembly. Okay, you have a housing, and you've got some absorbers there. Of course, you got a nut to secure it to the fan frame. And then you also have a turbine rear frame vibration sensor. And this is, I know I mentioned it earlier about the TRF is your turbine rear frame. I mentioned a bit ago when I was talking about the number 1 bearing sensor, because it's working with it. Okay, it's working in conjunction with the number 1 bearing sensor to monitor the engine vibration. Okay, and of course, you know, that signal's being sent to the computers, so it can, you know, also display on the ECAM. All right, now where is this TRF vibration sensor installed? Where is it located? Okay, this is located at the 12 o'clock position on the front flange of the turbine rear frame. So TRF, obviously on the turbine rear frame, but it's going to be at the 12 o'clock position. Okay, let's go ahead and go back to some potential test questions. Number 12, if you're following in your handout, what type of information does the EVS provide to the flight crew? Okay, this is the engine vibration system. Monitoring is the same thing. If I say EVS or EVMS, it's the same thing. It's the engine vibration monitoring system. Is it A, excess vibration, storage of balancing data, and frequency analysis? Or is it the second choice, which is excess vibration, storage of oil pressure, and oil sample analysis? Okay, so that's going to be option A. Number 13, which subsystem is used to perform troubleshooting? Is it your CFDS or your aids? Okay, if you recall, that was your aircraft integrated data system, your aids. Okay, number 14, which subsystem is used to initiate tests? Is it the CFDS or the ECAM? Okay, I mentioned that it was the CFDS, right? And where's the EVMU located? That's question number 15. Is it option A, the right-hand aft avionics bay, or is it left-hand forward accessory compartment? Okay, that's the first choice. All right, number 16. What does the EVMU do? Does it monitor the speed of the N1 shaft, or B, option B, computes the position and amplitude of the unbalancing? Okay, that's the latter answer. Okay, computes the position and amplitude of the unbalancing. All right. Okay. And number 17, the definition of engine unbalancing. By the way, I know there's the noun imbalance, but here we're talking about things like this. We're talking about the unbalancing of a component. Definition of engine unbalancing. Okay, remember I said before, it's an unbalancing of, or an unequal distribution of power that's going on within a closed system. Something's not at center. All right, number 18, the phrase engine unbalance is a possible setting on the EVMU menu. Is that true or false? I know I didn't mention before, but that answer is true. You will see the phrase engine unbalance. All right, so let's go ahead and get a little bit more into this, but we'll look at the indicating, the EVMU indicating, and also the interrogation, and then we'll go on to the N1 and N2 sensors. But let's look at I'm trying to see the board. Let's just first look at some of the indications. I know I just gave you a test question on one of them. You will see an engine unbalance as a phrase, on there. But as far as the way it's displayed, you've got vibration indications that are in green. Okay, and you have that. And then, of course, if there's I wouldn't say a warning, but if there's a caution, if something's starting to reach a certain level where it's of concern, then you're going to have a flashing, but it's going to be amber. And you'll have amber crosses that'll show up when that happens. Okay. The other thing that you might see is eng vibe sys fault. And that may come up if there's a fault, obviously, of the vibration system. Okay, I'm just giving you a few things you might see on there. Okay. All right, and then interrogation, your CFDS enables access to the systems, obviously. Your CFDS is going to give the maintenance information, and also you can, remember I said it's a place where you can initiate tests, so obviously that's there. All right, and of course ground failure, the EVMU is going to send a list of the LRUs that are, where there's something wrong with them. It's going to send that during it. It's going to show, those during a ground test. Okay, now the different ones that are going to be tested, by the way, by the EVMU are going to be your TRF vibration sensors left and right, your N1 bearing left and right, and also the EVMU. Okay. All right, I think covered pretty much, a lot of things that regarding the EVMU. Your accelerometers, remember I mentioned that to you before. Those are also monitored or checked for defects. There's something wrong with the accelerometers. That EVMU will be reconfiguring those if there's something wrong there. Okay. All right. I'm going to go into, there's some certain part numbers, but I'm not going to mention them because I don't want to confuse you. The best thing to do is just follow, what is given to you wherever you work, as far as, as far as parts. So I'm going to leave that alone. But this is regarding as far as unbalance, and that kind of thing. So anyway, just again, do pay attention to parts and don't just assume that they look alike. Oh, they must be, be interchangeable, because we know that's not necessarily true. Okay. All right. This concludes the session on engine vibration monitoring. We just covered quite a bit on that. And let's go ahead and get into session 4. This is going to be on N1 and N2 indications. I wanted to cover the indications first, so you understand, what can be displayed, and then we'll go to the actual, physical components and describing them and all that stuff. So, all right, okay, let's go ahead and move to that. All right, N1 and N2, very important to a pilot, as well as the exhaust gas temperature. That's certainly a whole new class and not really the focus of this particular lesson. But your N1 indication, N1 indications is showing, remember I said your N1 shows on the upper ECAM. Okay, so you're going to have that. It's going to display on there in the analog form and also in digital form. The analog form is going to be by a pointer that's going to be deflected in front of a dial, and then you have the digital form, okay, in the lower section of the dial. You also have other indications like your N1, your N1 max permissible, and your N1 max, okay, actual N1. You're also going to have N1 over limit, okay, also coinciding with your thrust lever 1 and 2, okay, or engine 1 and 2, thrust lever 1 and 2, below limit. So what kind of indications do you have here? If there's an N1 max, that's going to be a tick mark. Okay, it's going to be a small amber line that's going to show across the N1 analog scale. All right, so that you have that with that particular one. You're going to have a red tick. So I mentioned here you've got the tick mark for N1 max. You have a red tick mark that will show, and this is going to be when you have an exceeding past 102% of N1 speed. Okay, so there's a red arc that's max permissible, and then when it starts going past that max permissible, then that's when that red tick mark is going to show. Okay, and that's for N1. Okay, and then if you have some other ones you might see for N1, and a lot of these are going to go for N2 as well. I'm just kind of mentioning here. You'll see a white circle. The white circle, that one's going to show for N1 thrust, N1 THR throttle. And then you also have a blue arc as well. Okay, and that's going to be for actual, showing from actual value to your command. Okay, so it's very similar with N2. So when I'm mentioning these, it's similar, but N2 indicating. So now we're on to the N2 indicating part of their system, and N2 speed sensor. What's that going to do? It's going to detect the rotational speed, right, of the high pressure rotor assembly. Okay, and that's going to be sending messages to your EVMU, right, and also both your ECU channels. Remember, your ECU is your interface, okay, to your ECAM. All right. So other N2 indications, similar to N1. The only difference, of course, is going to be your percentage of speed. N1's going to be different as far as what's going to be considered exceeded past the limit. Your N2 is going to be a little bit different. Here on N2, if it's exceeding 105%, okay, of N2 speed, then you're going to have an indication that's going to turn red, and of course the master caution light is going to come on when that happens, and there'll of course be a sound that'll come on. If it goes past 105.8, okay, then you're going to have that indication, and the signal, it's going to be the same as the, as it passing 105%, but greater than 105.8%, you're going to have a display. On here it's going to be in red, the engine 1-2 into over limit, along with throttle lever, idle, engine master, 1 and 2 off. And there'll be a red cross to that'll appear. Okay. All right, so it's similar, just that the percentages are different because we have different speeds for speed requirements for N1 and 2. All right. Okay, let's do a few questions. Let's go ahead and go a few. All right, this is session 4, N1 and N2 indications. Number 19 in the handout. In digital form, how is the N1 indication displayed on the upper ECAM? Is it in the lower section of the dial, or is it B, by a point deflecting in front of a dial? Okay, the answer is A. Number 20, how is the N2 indication in normal mode displayed on the upper ECAM? Okay, normal's green, so this should be easy. Is it A, in the analog form highlighted in yellow, or green? Okay, I just said it's in green. Number 21, if N2 speed exceeds its limit, what does the display look like? Okay, is it option A, the indication turns amber and flashes 3 times every 4 seconds, or the indication turns red and a red cross is displayed? Okay, it's B. And of course, in general, if anything's exceeding a limit, then that's going to be in red. Okay, number 22, what is defined as exceedance of N2? Of N2 limit? Is it going to be when N2 is greater than 105 or when N2 is greater than 110? Okay, it's going to be at when N2 is greater than 105. Right? Okay. All right, so let's go back to our lesson here. All right, let's go to talking a little bit about start indications. So with N2, just one more indication that you can see, and it's not exhaustive because remember I said there are other main parameters it's not going to be covered here. But N2, if you start the engine, okay, the N2 indication is highlighted with a box, and it's going to have a gray background. So at engine start, whichever one's that's going to start, it's going to show on the display with a gray background. Okay. All right. All right, so that gives you an idea with some of the indications with N1 and N2. Okay, and let's go ahead and finish out some of these questions, and then we'll move on to in session 5, which we're describing the actual sensors. All right, let's go to question number 23 in your handout. What is the indication of either N1 or N2 highlighted by a box and a gray background mean? Okay, does it mean A, when the engine is started, or when engine is started, or when the thrust lever is in idle position? Okay, I just mentioned it's the first choice. All right, number 24, what does N1 indicate? Is it option A, current engine speed, or B, current thrust in pounds per square inch? Okay, it's the first choice. Number 25, when N1 is reaching a cautionary level, what happens on the display? Is it option A, the needle flashes an amber color, or B, a chime sounds twice every 5 seconds? Okay, it's letter A. Right, remember I said amber, cautionary. Okay, number 26, for N1 indication, what is the red tick mark? When does the red tick mark show up on the display? Is it A, when the max N1 is exceeded by 30%, or when the max permissible N1 is exceeded? Okay, it's going to be B. Okay, when the max permissible N1 is exceeded. All right, that concludes session 4 and the questions that you possibly, more likely will see. Let's go ahead and move on to session 5, where we're describing and understanding what the N1 and N2 sensors are and where they're installed, etc. All right, so let's go to looking at this. All right, the N1 speed sensor, these are speed sensors. Okay, so N1 speed sensor, first of all, where is it? Where can you find it? Okay, you're going to find that on the fan frame at the 5 o'clock position. Okay, how would you describe the speed sensors? Typically, they're going to be a 3 connected receptacle. You're going to have a flange and a head. Okay, and you've got a magnetic head. Of course, remember I said magnetism has to be part of all this. And then you've got 3 windings because you're trying to create an electromagnetic field. But you get 3 windings, your 3 permanent magnets, and of course pole pieces as part of that sensor. Okay. Now, just some things to be careful or be aware of when you're handling the sensors. They can break, so you don't want to put too much force when you're trying to secure them on the fan frame. If it doesn't go in right the first time, you feel like, oh, that is not, it needs to be tightened up. Don't continue doing that, because you just follow the torque requirements. Obviously, you don't want to damage the new parts that you're installing. So just be mindful of that. Okay. All right. Well, okay. And then that was for N1 sensor. And then as far as N2, it's similar, but you have a little bit of difference here. You've got a groove, which is going to, because it's not on the fan frame, it's actually on the accessory gearbox. That's where it's located. It's obviously has a way apart so that you can attach it to the accessory gearbox. So with here you have a groove in the sensor, on the sensor, that allows a seal to be made between itself and the AGB, your accessory gearbox. Okay, so it's slightly different. You still have 3 connectors to it and a flange, but the flange is just because you can attach it. As far as the clock position, it's at the 6:30 position on the accessory gearbox. Okay, so N1 is at 12 o'clock on the fan frame, and the N2 speed sensor is located on the accessory gearbox. That's test questions, guys. Okay, test questions. Okay, and they're long cables. Again, they're not very big, so it's important you don't handle them too roughly. I'm just saying that because if you try to think you tighten things down, there may be some leeway a little bit when you're doing that, but doesn't mean that you want to go past torque requirements, torque limits on it. Okay, let's go ahead and go to a few test questions. Where's the N1 sensor installed? That's question number 27, and of course 28 is where's the N2 sensor installed? Okay, 27 for N1 on the fan frame. N2 sensor on the accessory gearbox. Okay, simple. Number 29, what allows the transmission of information from ECU to ECAM? I know I mentioned this before. ARINC 429 is your standard database or data bus for the transmission of data electronically, right? Number 30, the body of the sensor, the body of this sensor, okay, has a groove that's going to accommodate it being able to be attached to the accessory gearbox. This is question number 30, by the way. Which sensor is it? Is it N1 or N2? Okay, I just finished mentioning it. That's N2. Okay, and we are on our last session, which is session 6. This is on the engine exhaust, the exhaust gas temperature, your sensors, and your indications. All right, so let's go ahead and get a little of information on this, and then we will be done with engine indicating. All right. Now, your exhaust gas temperature components, or I should say your system that you have, obviously you got a sensor, and that's located at an aerodynamic station. And if it's labeled that way, it's because it's labeled because that's where it's located. So, for example, T49.5, okay, T49.5 is designating where it's located, aerodynamic station 49.5, right? T is for temperature, by the way. Okay, so that's the EGT. And of course, that's going to be monitoring the engine's condition.